Hello, today's topic is sets. So, what is a set? Set is basically a collection of different objects, or we say elements, so which are actually compiled and put it in a curly bracket. This is actually called the denotion of sets, where we are suppose we are writing some vowels, so v is actually standing for the vowel, and the elements of v are going to be written in this a, e, I, o, and u. So this is basically the denotion of writing this thing within the curly brackets. Next thing is, what is element? I used a word here, element. If I say element or I say member, that both means the same. Elements are basically the number of objects in it, or numbers basically. The different numbers which we are going to write within the set are called element. They are individuals, and that is why we are calling them elements or members of the given set. Another thing is, when I write something which is NV, I used a vowel here and I denoted it with V. So here also I'm writing NV. That means number of elements lying in set V. So how many numbers we guys can see here? We can see 1, 2, 3, 4, 5. So there are 5 members in this. So that means the number of elements in V is 5. This is how we write the number of elements in a set. This is basically called the denotion of the set, how we denote it, and this is called number of elements. This is going to be a whole number every time. Whole number, or you can say a natural number. This number is always going to be a positive number, or we can say a whole number. Next thing is about the types of set. So there are two types of set. One is called finite and another one is called infinite. The name itself says everything. The finite basically stands for the number which we can count, or which are countable in number. And this word itself says that these are uncountable and infinite in number. Let's take an example for this. Suppose I have already written a set which is V, and V here stands for the vowel that we used, vowels, and the vowels examples are A, E, I, O, U. Second, I am taking E. E stands for the even number in the set. So E stands for the even number, and here I'm not defining till how many numbers we have to go. I'm not saying even number lying between 1 to 20, or I'm saying even number lying in between 30 to 50, right? So I'm not giving you any such sort of condition. I'm just saying even numbers. When I say even numbers, so you're going to start with the lowest one: 2, 4, 6, 8, 10, 12, and so on. Because it is going to be a lot in numbers and I cannot write everything in the paper, right? So this is how you're going to mark it when you know that it is already going forward and we are not supposed to write all of those numbers here. So that needs to be stopped here. Okay. Now we know that I know that NV is basically 5 in number because 1, 2, 3, 4, 5. It has 5 members. But if I'm going to write for NE, what I'm supposed to write here? I cannot write anything. These are infinite in numbers, right? This is the sign of infinity. These are infinite in numbers. Or basically, if you don't want to write the sign, just directly write infinite. So it itself means that this is an example of infinite set, and this is an example of finite set because we can count that. Now, let's take the next concept. Next concept, when we draw a sign like this means we are talking about some number which is belongs to. It is actually going to be a part of that set. If I mark a sign like this, that means it does not belongs to the set. Does not and does belong, right? So let's take some more special number sets. First one is about whole First one is about natural numbers. If I say natural number, the denotion here in the set theory is n. What is n? N basically starts from 0. And they are also uncountable numbers, right? This also a part of the infinite set. So I'm going to mark it like this. And if I want to make it on a number line, I'll be marking and I'll be starting this thing from 0, 1, 2, 3, 4, and so on, right? So this is going to be infinite in numbers. So it is starting from here and going in this direction. Second thing, if I say integers are denoted with Z. Integers are what? Integers are basically the natural numbers along with their negatives. This means the positive and the negative numbers both are counted in this. It actually starts from some negative numbers and I'm writing few of the numbers here like this, and 1, 2, 3, and so on. So it is uncountable from both the directions. We don't have the end point here. And if you also want to draw it on the number line, so it is all going to be a part of it. So it is going to start from here to here, all of these numbers. But these are basically the numbers, these ones, which is actually at a certain distance. I mean, we are not going to count it as 1.5. That's not going to be an integer. These are basically purely the natural numbers, which are not going to be in decimal form or the fractional forms. Third one is if I write positive integers. So when I say positive integer, z stands for the integer, but if I mark a plus sign here, that means we are talking about the positive integers. Here we are only going to count the positive numbers. If you already have these negative numbers, but we are going to start it from the positive ones, from these. Next is rational numbers. Rational numbers are denoted by Q. What is actually a rational number? Rational number is a fractional number. It should be written in P by Q form. This is the first part of it. Second thing is P and Q are going to be the integers. And third condition, that Q, the denominator, is not going to be equal to 0. So those are called rational numbers. Fifth, real numbers. Real numbers are denoted with R. Real numbers include both rational numbers and irrational numbers. That means all the numbers on the number line, whether it is positive, negative, whether it is anything, 0, 1, 2, 3, any number, it will be going in both the direction. And even the middle numbers or these values are also included, right? Irrational numbers are basically the numbers which can be written in this form, which cannot be written in P by Q forms. Now, let's understand the next thing, which is much more noticeable, which is called subset. What are subsets? Subsets is basically some elements which are a part of a main set. Is a part of the main set. Let me show you an example of this. If I say that set A belongs to 1, 2, 3, 4, 5, 6, 7, 8. And I'm saying that set B is 2, 3. Set C is 5, 9. And now I'm saying that B is a subset of A, which means that all the elements of B, like 2 and 3, are a part of this set. That's why we are calling B as a subset. And further, if we want to understand more, so if I'm saying like the elements, if I say 9 is a subset of A, is that a correct statement? No, because 9 is a part of C, but 9 is not a part of this A. A set belongs to only 1 to 8 numbers, right? So that's not possible. So it is not a subset. This sign actually indicates the subset. The bigger mouth stands for this thing, and this number is the bigger one. So that's why we are calling this as a main set. It is just like the greater and the lesser sign that we draw in inequalities. It's just the same thing. Next is, if I am drawing anything like this, or if I'm writing this, so this denotes the empty set. Basically, when there is no matching of the element or none of the element is there in the set, then we called this thing as the empty set. This is also called trivial subset, or we also call it null set. All of these names belongs to the same thing. Now the next concept that we are going through with union and intersection. Union means all together. Intersection means the common region or the common part that is counted in both the sets. So let's take an example. If we are taking A set as 1, 2, 3, 4, 5, 6, and B set as 2, 4, 8, 9. So if I want to write, okay, one more thing is there, that how do we denote union and intersection in the sets? U stands for the union and reversed U stands for the intersection. Which means if I want to write something for A union B, that will be 1, 2, 3, 4, 5, 6, 8, and 9. We are not going to repeat the numbers. We are only going to count the common numbers one time. This is about the union thing, in which we are taking all the elements together. And the next one is A intersection B. Here we are only going to write the common part. Common is 2, common is 4. So only 2 and 4 are the elements here. And I told you one more thing earlier, that is N A union B. That means we are talking about the number of elements in A union B. Let's count it together: 1, 2, 3, 4, 5, 6, 7, 8. So total 8 in number. And if I want to write for A intersection B, that is very simple, which we can look here, and this is 2. Okay. Now the next thing is disjoint set, or we call it mutually exclusive set. Mutually exclusive. Mutually exclusive itself means that something is exclusive here, right? Which is not common. And disjoint also means that there is a breaking of it, which is not even joining in any form. So whenever you guys see, if your set A intersection B is giving you a null, null set or the empty set, then we can say the given sets are disjoint. So here we can say A and B are mutually exclusive or disjoint sets. Now comes a very interesting topic, that means interval notation, or we call it set notation. This is very interesting as this is used for set builder notation. How we write the set, how we denote all the things. So let's understand it with an example. If I'm writing x slash negative 3, this inequality sign like this, and x belongs to all real values, right? So how do we describe this? If I want to write a proper statement of reading it, so I'll be saying x belongs to all real values from negative 3 to 5. One more statement I will add here, that minus 3 is included. Why I wrote minus 3 is included? Now let's try and understand this in a better way about this sign and this sign. When do we use this sort of sign and this sign? So there are two type of intervals. One is called open interval. One is called close interval. So I'm just going to classify these two in front of you, and I'll tell you what are the changes that we observe in open and closed. So when we say open interval basically means when we um, let me show you an example. If I'm drawing a number line, like I'm writing 5 here, and I'm marking a very small circle, which is a hollow one, and putting it like this. Okay. So this means that this point is not included in your solution. Okay. This point is actually not a part of your solution, but after that, everything is your solution. That means I'll be marking this thing as x should be greater than 5. I'm not putting a greater than equal to sign. I'm only writing a greater value sign. All the greater values than 5 are the solution of it, but not 5. Okay. And if instead of this, if I'm going to close interval, if I'm marking the same point here and marking a filled in circle here and putting the same thing here in the right direction, so this point is actually included in your solution, which I'm going to write as x should be greater than equals to 5. So whenever we write an inequality sign, that also means something, that we are counting that point or not. So both of things are different. And we also call this type of circle as open circle or a hollow circle. This is called filled in circle. Now let's come back to the same thing. If I'm drawing a number line, and here I wrote one thing, it's minus 3 to 5. So let's draw the same thing here. I'm drawing a value for x. This is from negative 3 to 5. And I said that this point is included and this point is not included. And all the in between values are your solution. So that's how we are going to mark it on a number line. That itself says everything. Okay. So this is all about the basics of sets. I hope you like the lesson. I hope if you guys have any question, please let me know. Have a nice day ahead.